You are receiving this video because you have some points to recover from your Unit 2 test in Geometry A. So what I need you to do is get out a sheet of paper, graph paper probably, because I believe there are some graphs here involved, and you'll need a straight edge and a compass, and take notes on the questions that you missed. Note, I am not going to do the actual questions on the test to preserve the secrecy of the test, the veracity of the test, but I will be giving you notes to take and record based on the problems that you missed. So jump to the problems that you missed, use the timestamps below this video to select the questions that you need to recover points on. Take detailed notes when you're done. Take a picture of your notes and submit that attached to a webmail. All right, without further ado, question number 1. You're given a drawing and asked to define it. Okay, this is based on the definition of perpendicular lines. Perpendicular lines are lines that intersect to form a 90-degree angle. Okay, and let's go ahead and sketch a picture of it. The angle formed is 90 degrees. We represent lines with arrows on both sides. And we represent a 90-degree angle with the square corner symbol. Okay, that's number 1. Number 2. Okay, it gives you a statement and then asks whether it's a conjecture, a definition, or a theorem. So let's go ahead and do that. I'm going to give you a statement of my own. A square, so this is number 2. A square is a quadrilateral with 4 congruent sides and 4 90-degree angles. Okay, is this a conjecture? A guess about what is true? Conjecture. A reasonable guess. Is it a definition? A precise description? Or is it a theorem? Something that has been proven. The answer is, it is a definition. It is a precise description that cannot be gainsaid. That is, a square is a quadrilateral with 4 sides, 4 congruent sides and 4 90-degree angles, and it works backwards too. If it has 4 congruent sides and 4 90-degree angles, it is a square. It is a definition. Okay, number 3. They give you a drawing and ask you about the steps used to determine whether 2 segments are congruent. So let's draw a triangle. So number 3. Okay. then let's label some things. A, B, C, D, E. Okay, how would you verify BC is congruent to DE with a compass? Okay. With a compass. And so what I would do is this. I would get my compass out. I'd place my compass point on B. Place my compass pencil on C. I would measure the distance between B, C with my compass. And then I would take it over to D and see if it also has the same length. So measure BC with the compass. And verify DE is the same length. Okay. Number 4. Number 4 says, okay, it gives us a drawing and says she folded her paper so that C was on top of D. Okay. All right. Okay. So here we go. We got a scenario in which we have segment AB, and we fold the paper to create so that A is on top of B and end up with this fold. Right here, which helps to identify point C. Okay, and we also happen to draw a line from A and a line from B and a line from C. And they all intersect at point D. Name the segment bisector of segment AB. Now a segment bisector, let's define that. Okay, goes through the midpoint. So if you look at it, there's only one segment that goes through the midpoint, or one line that goes through the midpoint, and that is CD. So the segment bisector is line CD. Not AD, because AD doesn't go through the midpoint C. Not BD, because BD doesn't go through the midpoint C. A segment bisector is a line, ray, or segment that goes through the midpoint of a segment. That's the segment bisector. Okay, question 5. Okay, it's talking about how to construct a parallel line, and it's talking about the steps. So for this, get your compass out. If you don't have a compass, then you can use the maths link. Let me put this up here. The constructions tool. So www.mathspad.co.uk for United Kingdom /i2/construct.php if you don't have a compass. But I prefer you do it with a compass. Okay? And here are the steps. Okay? I'm going to hide the grid because we shouldn't have lines on our paper for a construction. So we're going to start with a line. I'm going to label this line L. I'm going to put a point P on line off of line L. Okay, we're going to construct a parallel. So here's the first step. We're going to draw a line through P and L. Line through P and L. I'll call it T. Grab your compass or cab your grumpus. I'm going to label the intersection point A. So I have something to refer to. I'm going to put the compass point on A. Set the compass to anything convenient. And draw an arc that crosses both lines. Then I'm going to take the compass and put it on P and duplicate that same arc. Same size, same setting, same compass size. Okay, let me label some points so I can refer to them. We'll call this B and C and D. I'm going to take my compass and put it on B. I'm going to put the pencil on C. Make a little mark. That's called measuring the gap. I'm going to copy the gap to D. So keep the compass set the same size and draw an arc that intersects that arc. Label the intersection point E. And now I should be able to draw a line through P and E. Okay, and that's going to be parallel because the corresponding angles are congruent. Let's call this M. And we can say that L is parallel to M. Right, so that's number 5. Number 6. Okay, we have an angle doubling construction. So we're given an angle and we want to double it. So let's go ahead and do that. Number 6. So we're given an angle. Again, if you need a compass for this. If you don't have a compass, use the MathsPad link I gave you on question 5. So here's an angle. I'll call this point A. We want to double the angle. So doubling the angle basically is a matter of making a copy of angle A and attaching it adjacent to angle A. Okay, so here are the steps I would use. They can vary a little bit, but I'm going to grab my compass or cab my grumpus, put the point on A, set the compass to something convenient, and draw a circular arc that goes through both sides of the angle but continues on at least twice as far. Okay, and I'm going to label the intersection points B and C. Okay, Now, put your compass on B. Put your pencil on C. Measure the gap. Put your compass point on C and copy that gap outside the angle. Label the new intersection point D. And then draw ray AD. And we have constructed a new angle outside angle A, CAB. Okay? That is the same size. So angle BAC is congruent to angle CAD. Note the middle letter is always the vertex. Okay? And we could say also the measure of angle CDA or CAD is exactly half the measure of the combined angle, the measure angle DAB. Okay. So with a compass. Number 7. Okay. Number 7 is a question about constructing the angle bisector. So again, you need a compass. If you don't have a compass, use the MathsPad link I gave you on question 5. So go back to question 5 if you skip that one. Okay. And let's do this one. So this is number 7. Angle bisector. Okay, we start with a given angle. Call it angle A. And we want to split it in half. We want a ray that cuts it exactly in half. So here's how to do that. Take your compass and put it on A. Draw an arc that crosses both sides of the angle. I'm going to label those B and C. Now take your compass and put it on B. You can change the size of the compass here or not, but we're going to draw an arc in the interior of the angle. But between B and C, we've got to copy the same arc, so keep the compass setting the same. Put it on C and draw an arc that intersects the previous arc. Label the intersection point D and draw ray AD. Okay. I'm going to draw some auxiliary lines here, and just to note a couple things about this. If we connect B and D, you'll see there's a quadrilateral formed. And here's what we know based on what we used with the compass. We know that AC is congruent to BAB. We know that CD is congruent to BD. And this forms a kite. A kite has two sets of adjacent congruent angle sides. And we know that these two angles are going to be the same. So those are some things to highlight or point out about the angle bisector. Okay, question 8. Okay. I'm going to change the problem here, but I'm going to talk about the same idea. Okay. Let's say we start with an angle. So this is number 8. Start with an angle. Okay. And I'm going to construct the angle bisector. So let's construct the angle bisector. So take your compass, put it on the vertex. I'll label that A. Label the intersections B and C. Take your compass, put it on B. Draw an arc. On C, copy the same arc. Label the intersection D. Draw a ray AD. We've bisected angle A now. But now I want to bisect angle, and I'm going to label this point E now. I want to bisect angle CAE. Okay, so I'm going to shorten my compass here a little bit. Draw an arc from C, copy that arc from E. Okay, label this point F. Draw a ray AF. Okay, label this point G. Okay, so we've done all that. Here's the question I'm going to ask. If the measure of angle CAB equals 82 degrees, what is the measure of angle GAE? The measure of angle GAE. All right, let's see if we can figure that out. So the big angle here, right here, is 82 degrees. When we bisected that, we split that in half. So what is 82 degrees split in half? In other words, the measure of angle CAE equals 82 divided by 2, or 41 degrees. So this one's 41 degrees. Here, let's put this up here. Okay, so when we bisected that, we end up with this angle right here, half of that, angle GAE. Measure of angle GAE must be 41 divided by 2, or 20.5 degrees. And that answers our question. Okay. Number 9. Number 9 asks about the construction of a perpendicular bisector. So again, use a compass and straight edge. If you don't have a compass, use the MathsPad link I gave you on question number 5. So number 9, perpendicular bisector. Okay, so start with a segment. AV. Okay, draw a circular arc from AB, but make sure the distance from A is greater than the distance from B. So in other words, it's got to be greater than half the radius. And then draw the same arc, copy the same arc to B. Okay, that forms these intersections, C and D. Line up the straight edge with C and D. Through any 2 points there exists one and only one line in Euclidean geometry. Okay. And this is the perpendicular bisector. That is, AE is congruent to BE. Segment AE is congruent to segment BE. And the measure of angle BED, bed, is 90 degrees. Or we would say that DC, line DC is perpendicular to segment AB. Perpendicular bisector. Okay, number 10. Number 10 asks, determine the construction being done by the steps being shown. Okay, so we're going to do the construction and then we're going to name it. Number 10. So again, do this with a compass and a straight edge. If you don't have a compass and a straight edge, use MathsPad, the website that's given on question number 5. Okay, so here's the steps. It starts with a line. And a point not on the line. It then draws a line through the point and the line. And we'll call M. Well, I'm going to label the intersection point A. I'm going to take my compass, put it on A, draw an arc. Keep the compass the same size and copy that arc to point P. I'm going to label the intersection points B and C and D. Then I'm going to measure the gap BC by putting my compass point on B and my pencil on C. And putting my compass point on D and it creates the point E. And then finally I draw a line through P and E. And what have I produced? I've produced two lines that go side by side in the same direction, never intersecting, always remaining the same distance apart. So this is the construction. Of a parallel. That's the symbol parallel. Through a point not on a line. Okay. Number 11, we're getting down there here. It's asked to determine which set of lengths does not form a triangle. So for this one, I'm just going to give you some sets of numbers. We're going to determine whether or not they form a triangle. Okay. So here's the idea. The triangle inequality says that any two sides must add to more than the third side. It's sufficient to take the two smaller of the three sides, add them together and make sure they add up to more than the third side. So this is number 11. So if I have a triangle that has the sides 3, 7, and 10. Take the two smallest sides, 3 plus 7 equals 10, and 10 is not more than 10. Therefore, according to the triangle inequality, this does not work. Does not form a triangle. Okay? Now let's try this one. 8, 7, 14. 8 plus 7, the two smaller sides, is 15. 15. Which is more than 14. So it does form a triangle. Okay? 2, 25, 11. Take the two smallest sides, 2 plus 11. That equals 13, which is not more than the third side, 25. So this does not form a triangle. So the two smallest sides, must add to more than the biggest side. The requirement actually is that any two sides must be more than the third side, but if you start with the biggest side, it's going to be more than the other two automatically. So it's sufficient to check the two smallest sides and see if they add to more than the third side. Okay. All right, so number 12. Another question involving the triangle inequality. Okay, let's say we've got 3 locations. My house, the park, and the library. Okay. And this is question number 12. The question is asking, what does the triangle inequality say about this situation if the distance from the house to the library is 6 miles? The triangle inequality says that any two sides must add to more than the third side by itself. So here's what the triangle inequality says about this situation. The total distance from the house to the park and from the park to the library is more, can't be 6 miles, it's got to be more than 6 miles. That's what the triangle inequality says about this situation. Okay, question 13. Okay, I'll just answer this one here straight off. Define parallel and perpendicular lines, explain the difference between the two. Okay, so this has 3 parts really. So number 13. Parallel. Officially, in geometry, the definition is 2 lines on the same plane that never intersect. The lesson adds this to it. They remain the same distance apart. Now this would lead us to think that only lines can be parallel, but actually technically line segments and rays can also be parallel. And so the way we would define the segment that's segments that are parallel is the line containing the segments won't intersect, or the line containing the rays won't intersect. Okay? Perpendicular. Two lines intersecting to form a 90-degree angle. Okay? And explain the difference between the two. Parallels never intersect. Perpendiculars do. Okay, and let's give an example of each. Two parallel lines. Side by side together. No matter how far I extend it, it's going to be the same. Same distance apart. Perpendicular. Two lines intersecting to form a 90-degree angle. Okay. All right. Let me pause this. All right, question number 14. Almost done. Almost done. Okay. In 1 to 2 sentences, distinguish between definitions on undefined terms in geometry. And this one's an important one, and this one's a deep concept. Really can't be done in a very short answer here. But let's see if we can make sense of it. Okay, so this is question number 14. Okay, undefined terms. Okay, undefined terms versus definitions. It is necessary to have some words that are defined, that are undefined, or that are known in order to define anything. A starting point. Starting point. So to speak. Okay. So let's say you're trying to learn a language that has never been known, right? And you're trying to define it using the language. So let's say we're making up a new language called gibberish, and I want to define the word flamox or flabox, right? Make up a word that doesn't exist. And I define flabox. Flabox is to gibber and gabble and goob, right? Have I defined anything? Well, you don't know what gibber, gabber, and goob mean either. And so you haven't defined anything. You have to have some words to start with, right? These are undefined terms. These are terms that are simply known without definition. A starting point, so to speak. These are undefined terms. Okay. All defined terms then are ultimately defined by these. An example of an undefined term is point. Okay, I can try to describe it. It's this dot right here, but it's not really this dot because it has no thickness, no dimension, no width, no depth, no height. So it really can't be drawn. And it's at a particular location in space, right? Right now it's on my screen, but it exists in 3 dimensions, a point, right? And so we understand what a point is and we define things in terms of it. So we might define line by saying a line is 2 points and all points in between and beyond. And then of course we got to define what between and beyond means. But we define defined terms by undefined terms. Okay. So that's what I want you to say or write for number 14. Number 15, last question. Okay. Last question here. Okay, we have the sides of a triangle, so number 15. There are straws of these lengths. Length A is 2, length B is 9, length C is 11, length D is 7. Okay? How many triangles are possible? Okay, triangles have 3 sides. So here are the 3-letter combinations. We could do ABC. We could do ABD. And we could do ACD. Is that it? Or we could also do BCD. Note that if I scramble the letters, it's the same triangle. So ABC is the same as CBA. Is the same as BAC, and so on, right? So those are the only 4, we call them combinations of 3, right? In mathematics terms, in combinatorics, we call it 4 choose 3, choose 3 out of 4, right? 4 choose 3 is 4, for those familiar with that. Right, so ABC is 2, 9, 11. 2, 9, 11. Take the 2 smallest sides and add them. 2 plus 9 equals 11, which is not greater than 11. So no, this is not a triangle. ABD, 2, 9, and 7. Take the 2 smallest sides, 2 and 7. They equal 9, which is not greater than the 3rd side, 9. So this one is a no. Okay, we wonder if any are possible here. ACD, 2, 11, 7. Take the 2 smallest sides, 2 plus 7. That equals 9, which is not greater than 11. So no. Okay. And BCD, 9, 11, 7. Take the 2 smallest sides, 9 plus 7 equals 16, which is greater than 11. So yes. So in this particular case, BCD is the only triangle that can be formed. One triangle may be formed. It is triangle BCD. Okay. And that's it. Make sure to submit your notes attached to a webmail, and you can receive half credit back for the missed points, which makes a big difference.